Hello students, I am Sanjana Kavatigi, Assistant Professor, Department of Computer Science and Engineering, AITM, Belgavi. Let us continue with the video lectures on storage area networks. In this video series, I will be discussing about backup, archive and replication, which is module number 3 from the VTU syllabus for the scheme, that is 2017 scheme. Okay. In this video, we shall study Introduction to Business Continuity. In today's world, continuous access to information is a must for the smooth functioning of the business operations. The cost of unavailability of information is greater than ever, and outages in key industries cost millions of dollars per hour. There are many threats to information availability, such as natural disasters, unplanned occurrences, and planned occurrences that could result in inaccessibility of the information. Now, what could be planned occurrences? Planned occurrences may be like if I'm updating any server or any new feature is added to the software. That time we have to stop the running of the application. We have to shut down the application in order to upgrade the server or upgrading the software. In that particular time, it is going to be unavailable for the users to access. That can be planned occurrences. Unplanned occurrences can be any crashing of the database, or crashing of the storage device, or crashing of the processor. Anything could happen. That can be unplanned occurrences. In both the cases, it could result in the inaccessibility of the information. So therefore, it is critical for businesses to define an appropriate strategy that can help to overcome these types of crises. So business continuity is an important process to define and implement such strategies. Business continuity is an integrated and enterprise-wide process that includes all the activities which may be internal and external to IT industries that a business must perform to mitigate the impact of planned and unplanned downtime. So BC is nothing but business continuity. It is abbreviated as BC. It entails preparing for, responding to, and recovering from a system outage that adversely affects the business operations. So it involves many proactive measures like business impact analysis, risk assessments, BC technology solution deployments like backup and replication, which can be used in cases of data loss, and any reactive measures like disaster recovery and restart that are to be invoked in the event of a failure. So the main goal of a business continuity solution is to ensure that information availability required to conduct vital business operation. So the main aim of business continuity is to maintain the information availability that is required to conduct the vital business operations. So in a virtualized environment, this BC technology solutions need to protect both physical as well as virtualized resources. So virtualization considerably simplifies the implementation of BC strategy and solutions, that is business continuity strategies and solutions. So in this chapter, or in this video series, we'll be studying about the effect of information unavailability and the consequences of information unavailability. Also, we are going to study some key parameters that are going to be governed by any BC strategy, and we are going to study some roadmap to develop an effective business continuity plan. Next, we shall understand information availability. So what is information availability? It refers to the ability of an IT infrastructure to function according to the business expectations during its specified time of operation. So this information availability ensures that people like employees, customers, suppliers and partners of that particular business can access the information whenever they need it. So information availability can be defined in terms of accessibility, reliability and timeliness of information. So let us understand these three terms. What is accessibility? information should be accessible at the right place to the right user. That is the accessibility. Right user means he can be employee, or he can be customer, or a supplier, or a partner of that particular business. It should be accessible at the right place and to the right user. So that is nothing but accessibility. Next is reliability. Information should be reliable and correct in all the aspects. That means the user can rely on such information. The data should be uh, reliable and it should be correct in all the aspects that are required. So it is the same as what was stored, and there is no alteration or corruption to the information. Data integrity has to be maintained. That means the data what was stored has to be the same whenever we are going to access it. Okay, there should not be any alteration or any corruption to that particular information. So that is reliability. Next is timeliness. It defines the exact moment or the time window, like for a particular time of the day or a week, a particular time in the month or year as specified, during which the information must be accessible. Now suppose consider your VTU exam application. It will be accessible only from the start and end date of your application filling dates. Like suppose if they give time like from 1st September to 15th of September, you can fill your exam forms. That particular application will be accessible only during that particular duration of days. Okay. Another example, like if online access to an application is required between only 10 a.m. and 10 a.m. and 5 p.m. each day, and your the same application you can consider exam application only, it will be open from morning 10 o'clock to evening 5 o'clock each day during that particular time period what was mentioned. Okay, so any disruptions to data availability outside of this time slot are not considered to affect the timeliness. So that particular application has to be available at all the times within that particular time duration. Okay, if it is unavailable after that time period, it is not called as data unavailability because it has completed its timeliness. Okay, so this is about timeliness. Let us see what are the causes of information unavailability. Various planned and unplanned incidents that occur result in information unavailability. So the planned outages include any installation, integration and maintenance of new hardware, software upgrades or patches, taking backups, application and data restores, facility operations like any renovation or construction that are happening, and any refresh or migration of the testing to the production environment. These all can be planned occurrences. Okay, now what can be the unplanned outages? These include failure caused by any human errors or database corruption or failure of physical or virtual components. These can be unplanned outages. Okay, so another type of incident that may cause the data unavailability is any natural or man-made disasters like flood, fire, earthquake and contamination. Okay, so there is a figure that has been explaining disruption of disruptors of information availability. Okay, you can see in the figure the majority of outages are planned. Okay, most of the time it can be planned outage that is causing the information unavailability. So planned outages are expected and they will be scheduled but still cause the data to be unavailable. We know that some planned outages will be there, but still they cause data unavailability. So if we consider statistically, the cause of information unavailability due to unforeseen disaster is less than 1%. Okay, so you can see in the figure 80% it is planned outage, around 20% it is unplanned outage, and very less, that is less than 1%, it can be any of the disaster that are being occurred. Let us see some of the consequences of the downtime. Information unavailability or downtime results in loss of productivity, loss of revenue, poor financial performance, and damage to reputation. Loss of productivity includes reduced output per unit of labor, equipment, and capital. So, this loss of revenue includes direct loss, compensatory payments, and future revenue loss, billing loss, and investment loss. So, it includes first is direct loss, compensatory payments, future revenue loss, and billing loss, and the investment loss. So, poor financial performance affects revenue recognition, cash flow, discounts, payment guarantees, credit rating, and stock price. So, any damages to reputations may result in a loss of confidence or credibility with customers, suppliers, financial markets, banks, and business partners. So, other possible consequences of downtime include the cost of any additional equipments over rental or any overtime or extra shipping. So, these can be the other reasons for the downtime. The business impact of downtime is the sum of all the losses sustained as a result of a given disruption. So, an important metric that is average cost of downtime per hour. It provides a key estimate in the determining of appropriate business continuity solutions. It can be calculated as the term is average cost of downtime per hour, which is equal to average productivity loss per hour plus average revenue loss per hour. Okay. In turn, where productivity loss per hour can be calculated as where productivity loss per hour can be calculated as it is equal to total salaries and benefits of all employees per week divided by average number of working hours per week. Okay, this will give us the productivity loss per hour. And then we have average revenue loss per hour, which is equal to total revenue of an organization per week divided by average number of hours per week that an organization is open for business. Okay, so the sum of these two, that is productivity loss per hour as well as average revenue loss per hour, will give us the average cost of downtime per hour. The average downtime cost per hour, it may also include some estimates of projected revenue loss due to other consequences such as damaged reputations and the other additional cost of repairing the system in case of any damages that have happened to the system. Next we shall see measuring information availability. So, information availability relies on the availability of both physical and virtual components of a data center. Failure of any of these components might disrupt the information availability. So, a failure is the termination of a component's capability to perform the required function. Failure is nothing but it is a termination of a component's capacity or capability to perform the required function. The components the component's capability can be restored by performing an external corrective action such as any manual reboot, repair, or replacement of the failed component. Okay, so repair involves restoring a component to a condition that enables it to perform a required function. So proactive risk analysis that are performed as a part of the business continuity planning process. It considers the component failure rate as well as the average repair time, which are measured in mean time between failure and mean time to repair. That is MTBF and MTTR respectively. First, we shall see mean time between failure, that is abbreviated as MTBF. It is the average time available for a system or component to perform its normal operations between the failures. So it is measure of the system or component reliability and it is usually expressed in hours. Okay, so it is the average time available for a system or any component of the system to perform its normal operation between the failures, like first failure to the second failure. Between that time, the average time available that is available for the system to perform its normal operations. Next is mean time to repair, that is MTTR. It is the average time required to repair a failed component. So while calculating MTTR, it is assumed that the fault responsible for the failure is correctly identified and the required spares and personnel are available. Okay, so a fault is a physical defect at the component level which may result in the information unavailability. So that is called as a fault in this case. So this MTTR, that is mean time to repair, includes the total time required to do the following activities. Let us see what are those activities. Detect the fault, mobilize the maintenance team, diagnose the result, obtain the spare parts, repair, test and restore the data. These are the things that are being carried out in case of a failure. In the figure, it illustrates various information availability metrics that are required to represent the system uptime as well as the downtime. Okay, so here is the timeline that has been indicated. Uh, so here some timelines that are being marked as incident, diagnosis, incident, detection, diagnosis, repair, restoration, recovery. Okay, and then we have the cycle repeats. Again we have the incident. So the time between detection and repair will be the response time. The time between incident and detection is the detection elapsed time. Okay, so the time between diagnosis and restoration will be the repair time. Okay, so the time between restoration and recovery will be recovery time. So the time between incident and the recovery, it is going to be the time to repair or downtime. Okay, and then the time between recovery and the next incident will be the time between failures or the uptime. Information availability is the time period during which a system is in a condition to perform its intended function upon the demand. So it can be expressed in terms of system uptime and downtime and measured as the amount or percentage of system uptime. So information availability can be calculated as system uptime divided by system uptime plus system downtime. Okay, so where system uptime is the period of time during which the system is in a accessible state. It is in an accessible state. So when it is not accessible, it is termed as the system downtime. So system downtime means that the system is not accessible in that particular time. So in terms of MTBF and MTTR, that is mean time between failure and mean time to repair, it can be written as information availability is equal to MTBF divided by MTBF plus MTTR. Okay, so uptime per year is based on the exact timeliness requirements of the service. So this calculation leads to the number of nines representation for the availability metrics that is given in the table. You can refer from the textbook. So this is about measuring the information availability. The next concept is BC terminology. In this section, we shall study the introduction and definitions of some common terms related to business continuity operations. First one is disaster recovery. It is the coordinated process of restoring systems, data, and the infrastructure required to support ongoing business operations after a disaster occurs. So it is the process of restoring a previous copy of the data and applying logs or other necessary processes to that copy of data to bring it to a known point of consistency. To bring that particular data to a consistency state, we should apply some logs and other necessary processes or any other operations to that data and get it to the normal consistent state. So after all the recovery efforts are completed, the data is validated to ensure that it is correct. So once you make any correction to that data, you're going to validate that data to check the correctness of that particular data. Next is disaster restart. It is the process of restarting the business operations with mirrored, consistent copies of data and applications. Next is the recovery point objective, RPO. It is the point in time to which systems and data must be recovered after an outage. It defines the amount of data loss and that a business can endure. So a large RPO signifies high tolerance to information loss in a business. So large RPO value means that the business is highly tolerant to the information loss. Okay, so based on the RPO, organizations plan for the frequency with which backup or replica must be made. For example, consider if the RPO value is 6 hours, backups or replicas of the data must be made at least once in 6 hours. Okay, so if the RPO value is 6 hours, the backups or replicas or mirror of that data should be done once at least in 6 hours. Okay, in the figure 9.3 it shows various RPOs and their uh, corresponding ideal recovery strategies. So an organization can plan for an appropriate BC terminology uh, solution on the basis of a RPO that is set for it. Okay, for example, consider RPO of 24 hours. So the backups are created at an offsite tape library every midnight. That is once in 24 hours. Okay. So the corresponding recovery strategy is to restore data from the set of last backup tapes. Okay. The corresponding recovery, how the recovery will be made? A recovery is taken from the last backup tape. Okay. So in that from that particular tape, the data will be the that data will be the recent one, so that will be taken for recovery. Next, RPO of 1 hour. Shipping database logs to the remote site every hour. The corresponding recovery strategy is to recover the database to the point of the last log shipment. Okay, again it is taken from the last log shipment for the recovery. Okay, so if RPO is in order of minutes, then mirroring data asynchronously to a remote site. Asynchronously, we are going to mirror the data to a another site which is at the remote place. Okay, the last one is near zero RPO. So this will be mirroring data synchronously to a remote site. Synchronously in case of near zero RPO, asynchronously in case of RPO in terms of minutes. Okay, so in the figure you can see recovery point objectives as well as recovery time objectives. Okay, so you can see in if it is in case in terms of seconds, in case of recovery point objective, in seconds it is synchronous replication, in minutes it is asynchronous replication, in hours it is in between periodic replication and asynchronous replication, in terms of days it will be a periodic replication, weeks it will be a tape backup. Okay, if it is recovery time, then in terms of seconds it will be a global cluster. If it is in terms of minutes it will be a manual migration. If it is in terms of hours and days it will be disk restore. If it is in terms of weeks it will be a tape restore. The next term we have is recovery time, RTO. The time within which systems and applications must be recovered after an outage is nothing but the recovery time objective. It defines the amount of downtime that a business can endure and it can survive. So businesses can optimize disaster recovery plans after defining the RTO for a given system. For example, if the RTO is of 2 hours, it requires task based backup because it enables a faster restore than a tape backup. So, however, for an RTO of 1 week, tape backup will likely meet the requirements. Some examples let us consider. If RTO is of 72 hours, it restores from the tapes that are available at a Coldsite. RTO of 12 hours, restore the tapes from that are available at a Hotsite. What is Coldsite? What is Hotsite? We have these two terms. Okay, they are also BC terms. We shall see after this. So RTO of few hours, if RTO is of few hours, then it will use the data vault at a hot site. And RTO of a few seconds, uh, cluster production serves with bidirectional mirroring, enabling the applications to run at both sites simultaneously. Okay, so this is about RTO. Next term we have is data vault. It is a repository at the remote site where data can be periodically or continuously copied. That is to either tape drives or disks. So that there is always a copy at the another site. Okay, so it may be continuous or a periodic copying of the data, or either to the tape drives or disks, just to make sure that we always have uh, another copy of that data at another site. Okay, the next term we have is hot site, a site where an enterprise's operations can be moved in a event of disaster. So it is a site with the required hardware, operating system, application, and network support to perform the business operations, where the equipment is available and running at all the times. So that is nothing but hot site. The next term we have is cold site. It is a site where an enterprise's operations can be moved in the event of a disaster with minimum IT infrastructure and environmental facilities in place but not activated. So that is nothing but the cold site. The last term in BC terminology is server clustering, a group of servers and other necessary resources coupled to operate as a single system. Clusters can ensure high availability and load balancing. Typically, in failover clusters, one server runs an application and updates the data, and another server is kept as standby to take over completely as required. In more sophisticated clusters, multiple servers may access data, and typically one server is kept as a standby system. So, server clustering provides load balancing by distributing the application load evenly among the multiple servers within the cluster. So, this is about server clustering, and we have covered all the BC terminologies. Thank you for watching.